Hello everyone, welcome to CH for us. Today we'll be doing problems related to mole concept. Calculate the mass of Na2CO3 which will have the same number of molecules as contained in 12.3 grams of MgSO4.7H2O. So here they have asked us to calculate the mass of Na2CO3. They have given that the number of molecules in Na2CO3 is equal to the number of molecules in 12.3 grams of MgSO4.7H2O. Okay, this is given. So first we have to find out the number of molecules present in 12.3 grams of MgSO4.7H2O. 1 mole of MgSO4.7H2O is equal to the gram molecular mass of MgSO4.7H2O is 246 grams. So magnesium's atomic mass is 24, sulfur's is 32, oxygen is 16. You have to multiply it with 4. Then you have 14 hydrogens. Then you have 7 oxygen atoms again. So you have to add it, you will be getting 246 grams, which is equal to 6.022 into 10 to the power 23 molecules. For 246 grams, 6.022 into 10 to the power 23 molecules. Then for 12.3 grams, the number of molecules is how much? 12.3 into 6.022 into 10 to the power 23 by 246. To make the calculation easier, I'll be multiplying 12.3 into 10, which will be 123 into 6.022 into 10 to the power 22 by 246. 123 ones are 123 twos are 2 ones are 2 3.011, which is equal to 3.011 into 10 to the power 22 molecules are present in 12.3 grams of MgSO4.7H2. Therefore, the number of molecules in Na2CO3 is 3.011 into 10 to the power 22 molecules. Now you have to find out the mass. So how do you find out the mass? 1 mole of Na2CO3 is equal to 106 grams. This is the gram molecular mass of Na2CO3, which is equal to 6.022 into 10 to the power 23 molecules. Then what will be the mass of 3.011 into 10 to the power 22 molecules? 3.011 into 10 to the power 22 into 106 divided by 6.022 into 10 to the power 23. So this one and this one gets cancelled. Ones are, twos are, 2 ones are 53. 53 by 10 is 5.3 grams. So the mass of Na2CO3 is 5.3 grams. Now we will see the next question. Calculate the volume occupied by 10 to the power 22 molecules of a gas, which gas they did not mention, at 300 Kelvin and 760 mm pressure. Keep in mind that 760 mm is equal to 1 atmospheric pressure. Okay. Now they have asked us to find the volume occupied by 10 to the power 22 molecules. So for 6.022 into 10 to the power 23 molecules at STP, the volume occupied is 22.4 liters. Then for 10 to the power 22 molecules, the volume occupied at STP is 10 to the power 22 into 22.4 divided by 6.022 into 10 to the power 23. 22.4 divided by 60.22, which is equal to 371.9 or 8 centimeter cube. Okay. You have to calculate it and see whether it is correct or not. After the decimals, you have to see. Okay. So we have calculated the volume of 10 to the power 22 molecules at STP. Now, the given conditions and the STP conditions. You have to note down. V1 is how much? This you have to find it out. Then P1 pressure given is 760 mm, which is also equal to 1 atmospheric pressure, and T1 is 300 Kelvin. Okay, 300 Kelvin. Now at STP, V2 is equal to how much? You have to write this, 371.9 centimeter cube. P2 at STP, at standard temperature pressure, what is the pressure? 1 atmospheric pressure. And T2 is equal to 273 Kelvin. Now we know that P1 V1 by T1 is equal to P2 V2 divided by T2. So what is P1 here? 760 into V1 you have to calculate. T1 is 300, which is equal to P2 1 into V2 371.9 by T2 273 Kelvin. Now you have to calculate V1, which is equal to 371.9. This 760 mm you can take it as 1 atmospheric pressure. Okay, 371.9 into 300 divided by 273, you'll be getting something around 408.8 centimeter cube. First you'll be getting it in liters, 0.4088 liters you'll be getting. That you have to convert it into centimeter cube, which is 408.8 centimeter cube. Why? 1 liter is equal to 1000 centimeter cube. You have to keep this conversion also in mind. So this is method 1. You can solve this problem by taking a ideal gas equation. I'll show you that. Method 2. First we will calculate the number of moles. How do you calculate number of moles? Number of moles is equal to number of entities by Avogadro's number. By Avogadro's number. So number of entities means atoms or molecules. So here they have given 10 to the power 22 molecules. So you have to take 10 to the power 22 by Avogadro's number 6.022 into 10 to the power 23. 1 by 60.22, which is equal to 0.0166 moles. N is equal to 0.0166 moles. Now we have to take our ideal gas equation. PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is the gas constant, universal gas constant. R is equal to 0.0821 liter atmosphere by Kelvin moles. Okay, this one also you have to keep it in mind. And T is temperature. So what is P? P is 760 mm. 760 into, see here we have taken R as atmospheric pressure. So even this pressure, you have to write it as 1 atmospheric pressure into V, we are going to find that out. Next, N is number of moles, 0.0166 moles into R is universal gas constant, 0.0821 liter atmospheric pressure by Kelvin mole into temperature is 300 Kelvin. Okay, now we will first cancel the units. Kelvin and Kelvin gets cancelled, mole gets cancelled, atmospheric pressure and atmospheric pressure gets cancelled. So V is equal to 0.0166 into 0.0821 into 300 liters, which is equal to 0.4088 liters. Now this you have to convert it into centimeter cube, which will be 408.8 centimeter cube. Volume occupied by 10 to the power 22 molecules of a gas at 300 Kelvin and 760 mm is 408.8 centimeter cube. Find the number of atoms of each type present in 3.42 grams of cane sugar. So here they are asking us to find out the number of atoms of each type. Each type means number of atoms of carbon is equal to how much in 3.42 grams of cane sugar. Number of atoms of hydrogen is equal to how much in 3.42 grams of cane sugar, and number of atoms of oxygen is equal to how much in 3.42 grams of cane sugar. So first, 1 mole of C12H22O11 is equal to 342 grams. The gram molecular mass of C12H22O11 is 342 grams, which is equal to 6.022 into 10 to the power 23 molecules. Then for 3.42 grams, the number of molecules is equal to how much? 3.42 into 6.022 into 10 to the power 23 by 342, which is equal to, I'll multiply 3.42 into 100. So that will become 342 into 6.022 into 10 to the power 21 by 342. 342 and 342 gets cancelled. So the final answer will be here 6.022 into 10 to the power 21 molecules of C12H22O11 is present in 3.42 grams of cane sugar. Now you have to find out the number of atoms. First, of carbon is equal to, here we have 12 atoms in cane sugar. So you have to multiply the 6.022 into 10 to the power 21 with 12. 6.022 into 10 to the power 21, which is equal to 72.2 into 10 to the power 21, which is equal to 7.22 into 10 to the power 22 atoms of carbon is present in 3.42 grams of cane sugar. Okay. Now number of atoms of hydrogen is equal to, hydrogen here is, we have 22 hydrogen atoms. 22 into 6.022 into 10 to the power 21, which is equal to 132.4 into 10 to the power 21 atoms, which is equal to 1.324 into 10 to the power 23 atoms of hydrogen is present in 3.42 grams of cane sugar. Now number of atoms of oxygen. We have 11 atoms here of oxygen. So 11 into 6.022 into 10 to the power 21, which is equal to 66.2 into 10 to the power 21, which is equal to 6.62 into 10 to the power 22 atoms of oxygen is present in 3.42 grams of cane sugar. Okay. Now we'll see the next question. Calculate the volume occupied at STP. STP means standard temperature pressure, and here the substance taken will be gas molecule. Okay, so 16 grams of oxygen, you have to write it as O2. You have to find the volume occupied by 16 grams of O2 at STP is equal to how much? 1 mole of O2 is equal to 32 grams, which is equal to 22.4 liters. Then 16 grams of oxygen occupies how many liters? 16 into 22.4 by 32, which is equal to 11.2 liters. So the volume occupied by 16 grams of oxygen is 11.2 liters. Okay. Next, the volume occupied by 1.5 moles of oxygen. 1 mole of oxygen, it occupies 22.4 liters. Then 1.5 mole of oxygen is equal to how much? 1.5 into 22.4 divided by 1, which is equal to 33.6 liters. So the volume occupied by 1.5 moles of oxygen is 33.6 liters. Now we have to find out the volume occupied by 6.022 into 10 to the power 23 molecules of carbon dioxide. So 1 mole of CO2 is equal to 6.022 into 10 to the power 23 molecules of CO2. So in question also they have asked the volume occupied by 6.022 into 10 to the power 23 molecules of CO2, which is equal to 22.4 liters. So 22.4 liters is the answer here. Okay. Next question. How many grams of H2S are present in zero point 0.4 moles of H2S? They are asking us to calculate the mass of H2S in grams in zero point 0.4 moles of H2S. 1 mole of H2S is equal to 34 grams. 32 is the atomic mass of 32 AMU is the atomic mass of sulfur, and hydrogen is 1. So 2 into 1 plus 34 is 34 grams. 32 is 34 grams. Okay. 2 into 1 plus 32 is equal to 34, which is equal to 6.022 into 10 to the power 23 molecules of H2S. Now they have given us zero point 0.4 moles of H2S. What is its mass? They are asking mass. 0.4 into 34 divided by 1, which is equal to 13.6 grams. Okay. So the how many grams of H2S is contained in 0.4 moles of H2S is 13.6 grams. Now we'll see the second one. You have to calculate the gram atoms of hydrogen and sulfur. How many gram atoms of hydrogen and sulfur are present in 0.4 moles of H2S? So 1 mole of H2S. See, I have already said 1 gram atom is equal to gram atomic mass. Okay. So the 1 mole of H2S is equal to 34 grams, which is equal to 1 gram atom. Then for 0.4 moles of H2S, gram atom is how much? 0.4 into 1 by 1, which is equal to 0.4 gram atoms are present in 0.4 moles of H2S. Now you have to find out the gram atoms of hydrogen and the gram atoms of sulfur. So in H2S, we have 2 atoms of hydrogen. So 2 into 0.4 gram atoms is equal to 0.8 gram atoms of hydrogen is present in 0.4 moles of H2S. Then sulfur you have only 1. So 1 into 0.4 gram atoms is equal to 0.4 gram atoms of sulfur is present in 0.4 moles of H2S. We'll see the next question. How many molecules of H2S are present in 0.4 moles of H2S? They have asked us to calculate the number of molecules is equal to how much? In 0.4 moles. In 1 mole of H2S, we have 6.022 into 10 to the power 23 molecules. Right. Then in 0.4 moles of H2S, the number of molecules is equal to how much? 0.4 into 6.022 into 10 to the power 23 by 1, which is equal to 2.4088 into 10 to the power 23 molecules of H2S is present in 0.4 moles of H2S. Okay. In fourth one, they have asked us to calculate the number of atoms of hydrogen and sulfur separately. So we have in H2S 2 atoms of hydrogen. So 2 into number of molecules of H2S in 0.4 moles of H2S, which is equal to 2.4088 into 10 to the power 23, which is equal to 4.8176 into 10 to the power 23 atoms of hydrogen is present in 0.4 moles of H2S. Then what about sulfur? We have only 1 atom of sulfur. 1 into 2.4088 into 10 to the power 23 is equal to 2.4088 into 10 to the power 23 atoms of sulfur is present in 0.4 moles of H2S. Next question. You are supplied with a gas containing 0.32 grams of oxygen. Calculate the number of moles and number of molecules present in it. So, you have to calculate number of moles and number of molecules of what? Of oxygen, O2. They have said already it is a gas. So O2, diatomic gas. 1 mole of O2 is equal to 32 grams. Then 0.32 grams of oxygen contains how many moles? 0.32 into 1 divided by 32, which is equal to 0.01 moles of oxygen gas is present in 0.32 grams of oxygen. Okay. Now, you have to find out the number of molecules is equal to how much? 1 mole of O2 is equal to 32 grams, which is equal to 6.022 into 10 to the power 23 molecules. Then for 0.32 grams, number of molecules is equal to how much? 0.32 into 6.022 into 10 to the power 23 divided by 32. For easy calculation, we'll multiply 0.32 into 100. So 32 into 6.022 into 10 to the power 21 divided by 32. So 6.022 into 10 to the power 21 molecules of oxygen is present in 0.32 grams of oxygen gas. Okay.